Okay, so the sine extension lesson, the optional one here at the end of the sine unit. So first of all, really, the addition here that I'm going to put in is this, is we can find, you recognize probably right away, this is the opposite side, no big deal. If we find that, we can actually find this side as well, using the Pythagorean theorem. And while we're at it, we can actually find this angle right now, because the two angles, the two non-right angles, the two non-90 degree angles in a right triangle, they have to add up to 90. So for example, I can find this angle, I'll call it phi or phi, I can never remember which one it is, would be 90 minus 39, which is going to be 51 degrees. So you can do that right off the bat. Then we're going to still use this angle, though, to find this opposite side. And then we're going to use Pythagorean theorem to do this. Or, I guess technically you could use the sine to find this, because this and this angle is this is the opposite for that angle. Yeah, your call. In fact, I'll look at it both ways. But starting off, let's find this opposite side. So it's going to be, we'll do it up here. We'll say the sine of 39 degrees is equal to the opposite, and call that x. I'll call this side, by the way, y for now. Not that it's important right now, but opposite over hypotenuse, which is 152. And so I multiply both sides by 152, and x is going to be equal to let's see, 152 times the sine of 39 degrees, and I get 95.7. Now you have an option. You could do Pythagorean theorem to find this. You would simply, y would be equal to the square root of 152 squared plus, not plus, minus 95.7 squared. So that would be one way to do it. And if you did it real quick, that would be 152 squared minus 95.7 squared. And that comes out to be a value of y to be 118.1. Or, not to give you too many options, but you could now, instead of considering yourself at this angle, you could go stand in this corner. And for this corner, this is the opposite side. And so the sine, I can slide this in down here, I guess. So the sine of a 51 degree angle, notice I'm using this angle now, is equal to the opposite, y, over the hypotenuse, 152. And I could find y using that, which should be 152 times the sine of 51 degrees, 118.1. What do you know? So either way, we should get the right answer. And there'll be some variation, but your job is to find all the missing angles and sides. So the other missing angle, once you know one of the angles, you just subtract from 90, no big deal. Use the sine to get one of them, and then you can either use the Pythagorean theorem or turn your perspective and use the sine again. Let's take a look at this one down here. So if this angle is 50, right away I could figure that this one's got to be 40, because they have to add up to 90. If I stay on this angle, this is the hypotenuse, so I'm going to call this x and this y. This is the opposite side for the 50. So one thing I could do is I could go sine of 50 degrees equals x over 6.2. And I could solve that, I could solve that for x. At the same time, I could also say that the sine of 40 degrees is equal to y, the opposite side for it, over 6.2, and solve that. And so 6.2 times the sine of 50 That gives me x is 4.75, and 6.2 times the sine of 40 gives me 3.99, basically 4. Now, I could get one. Once I got this one, I could do Pythagorean theorem. I could do 6.2 squared minus 4.75 squared, and then take the square root. And I get 3.98, so yeah, about 4. That works. Now, sometimes you might run across a problem like this. This scenario here you could picture, for example, is Evel Knievel. It's a guy who used to like jump motorcycles over big things. You probably don't remember anything like that because it was in the 70s. But anyway, so imagine some stunt guy who jumps motorcycles. Well, he comes and tells you that the launch angle for his ramp has to be 20 degrees. And this is like a fixed piece of a building or something like that. It's got to start at 4.5. And he says, you have to go to the store and buy a board long enough. This is 4.5. You have to buy a ramp, a piece of metal or board long enough to make up that ramp. So basically, he's asking us to find the hypotenuse. We have the opposite side. So you, being a smart assistant, would be like sine of 20 degrees equals 4.5 meters over the hypotenuse. Now, of course, we'd have to switch these two. So our missing hypotenuse would be 4.5 meters divided by the sine of 20 degrees. So that would be 4.5 divided by sine of 20. And it would be 128.9 meters. So you probably go by 130 meters worth of board, just cut a little off. I don't know if you can buy a board that long, actually, but you get the idea. This one is just going to be another one of where they want you to find everything. I'm actually going to change this one. Give me a second. I'm going to change this one. I'm going to say we don't know this angle. And I'm going to say, let's see. So let's go. All right, I'm going to say this side is 20.1. Now, in this situation, I'm giving you two sides. And I want you to find the missing side and both angles. Now, in this case, this is a crucial angle because this is the opposite and this is the hypotenuse. So this is the angle where the sine is going to be useful. So I'm going to call that theta and this phi. And I'm going to go after this angle first because I have the hypotenuse. And then if I consider this, that's the opposite. If I tried to find this one first, I don't have the opposite. And so that would be tough with the sine. So we're going to go after this angle first. We're going to say that the sine of the unknown angle is the opposite, 18.5, over the hypotenuse, which is 20.1. And if you remember, that means the angle is the inverse sine, the second sine, of whatever you get when you do 18.5 divided by 20.1. So I'll go 18.5 divided by 20.1, and then do second sine, and I get 67 degrees. Now that I know that's 67, I can find this pretty easily by subtracting from 90. That's going to be 23. Just double check it, 6, 8, yep. And now I could use Pythagorean theorem to find this, or I could use the sine again. I'll use Pythagorean theorem. So we're going to go 20.1 squared minus 18.5 squared, and then take the square root of that, 7.86. I found all the missing pieces. So yeah, if you start off without having any of the angles, just have to identify which angle you want to try, which angle you have the opposite and hypotenuse for. Of course, if you did Pythagorean theorem and got this side first, then you could really choose either one. It's your call.